Okay, so this demonstration is going to be a demonstration of the assembly and the animation for a couple different types of gumball machine candy dispensers. And we might make it 2 videos. Let's see how long it goes. But the animation is going to include the full animation of the gumball going through the machine, and if we have time, we'll do a quick reboot or recover, re-go over the explanation of how to animate the camera. Okay, so the spiral one does that, and the other one, let's see, does this, and this one includes a demonstration of how to make the gumball roll as it goes. That is not a requirement, but something interesting you can add. And this one is a little more traditional as far as the animations are mostly about constraining the center point to one of the origin planes. I think you can see the gumball, the first gumball there, the distance from the YZ, the distance from the XZ, and the distance from the XY. That is the only thing that's changing to make it move. The rolling or the angle constraint of the ball is just the added on at the end. Okay, so let's start a fresh assembly, and we will do the spiral one first. Let's go ahead and place the, is it in this one or is it in the one above it? The spiral, gumball spiral, and we'll place the base. And because we have place and ground first component origin on, we are good to go. And now we can place the case, which for almost the entire time will be invisible, but either way, let's make this to one of the that center origin, and we'll turn off auto predict because we don't want it offset. And let's go ahead and mate this surface to this face, the small face right there. And even though it still spins, that doesn't really matter. Okay, so let's go ahead and place the spiral, which is that one. And same thing, because we made everything on the origin planes, all the origin axes are going to be good, so we'll go ahead and mate that to something that shares the axis, which is everything, including the assembly's y-axis. That's good to go. And we need to lock it down to the ground. In fact, this is a good time to turn off the visibility of that case because it's not doing us any good. Let's go ahead and mate this face to this face. And actually, is that right? That is right, because I made the spiral there go down below, so it actually digs in so that this surface of the green part continues to the yellow part without a bump. Even though that's not going to affect the animation, it will look better, which is sort of the point. And we need to lock it in place, which for something that isn't going to move, which this spiral isn't going to move, you can technically just put it where you think it looks good, right click and ground it. It doesn't have to be constrained, proper constrained, but if you wanted this to be constrained, you could, let's see here, you could constrain, you could make this edge to this edge, I think. Yep, that's one way to put it in. I don't know. And click and drag to make sure everything is good. Alright, next thing we'll place, let's we need to turn the visibility of the base back on, and we'll place the cylinder cradle, which is this piece, and it gets mated from that face to this face right here, which is flat, and we're going to mate the center axis to the center axis of everything. All those share the same point, and you can see how the gumball, well, you will see how the gumball falls through that hole. And in fact, I need to cut off a part of this. Let's well, we can do it in the assembly technically. Let's put a sketch on here. Even though I don't show you guys how to do this, you can edit parts in the assembly, but then you have to do a couple other things. Let's cut it off until it goes below there. You can actually change it to 2, and you want to cut extrude until it gets to the height of that face, and return, and we're good to go. Okay, we'll save it here, and gumball spiral. Let's call it gumball spiral assembly 2. And yes, still on. Okay. All right. So the cradle, I want the gumball to drop down when it goes through that to a spot on the green spiral that is at least a gumball away, so that it can keep going. That's about right. So let's do a, well, doesn't really matter. Let's just go ahead and ground it. Could do, the proper way would be to do an angle constraint. Let's do an angle constraint of that as it is to one of the vertical planes of the origin, which, nope, that's not what I want. I want one of the vertical planes, and this should be stuck. There we go. That's good. Okay, let's clean this up a little bit, and let's add the cylinder, which I know that this, the axis of the cylinder lines up exactly with the axis of the cradle, but I need to lock it in place, and one way I can do that is by creating a work plane that is exactly in the middle of the hole there, and mate that work plane to the center axis of the hole in the cradle. So let me open up this part file, and I have actually made this work plane before, but the way you can make a work plane exactly between 2 faces, you can click on work plane, click on one face, click on another face, and it will make a work plane that slices it right down the middle. We'll save this, and now we can mate that new work plane to the center axis of this hole with no offset, and now it is directly centered on the hole of the cradle. Let's turn off that work plane, which we can do from here. Visibility, and it should be persistent, but that doesn't really matter. And let's go ahead, and we need to constrain it from moving, from rotating the way you would use it, and we need to constrain it from doing that because that's what we're going to animate. So let's do an angle constraint of this. Let's do constrain angle first type to the origin XZ, which is that one. And I changed my mind. I want it to be 180 degrees because I want the cylinder to start facing down. So the first animation is of it turning around to collect the gumball, which will be in this area. actually, at this point, I'm going to go ahead to Inventor Studio, start the animation, even though there are no gumballs. Let's go ahead and animate that cylinder's angle constraint. And we want it to go from 180 to, let's go, keep going positive to 360 over the course of 1 second. And it didn't flip, or it did flip, because we're missing a constraint. All the constraints that are on it so far, the cylinder axis to the cradle, the plane to the axis of the hole in the cradle, and the angle constraint that we're animating, can still be satisfied when I do that animate. So we need to put on a different constraint. Let's do a predict offset flush between this face and whatever plane is going. Oh wait, that's not gonna work. Let's try an angle of that to that. Hit OK. Nope. Let's try from that to that. Hit OK. Nope, it's not that. Tell you what, let's get rid of. Let's line up the cylinder cradle. Just getting ahead of myself, because let's make sure that is going to a origin plane. So let's do a predicted flush of this to that. Nope, let's set up an angle of that. There we go. Apply. And then we'll do a flush with predicted of that to that. Hit OK. Let's accept that and get rid of the one that it breaks, which should be OK now because the flush is going to be a stronger constraint. So now we have it going around. There are going to be several times where we make a constraint and just to put it in the right place, then do another constraint that predicts the offset and then delete the first constraint. And that was an example of that. So now we have it going over to collect the first gumball, which doesn't exist yet, and then we have an option of either having it go back the other way, which would be like that, or that was a mirror, or we could right click copy this and then right click paste it, in which case it would be going from 180 to 360 and then from 360 to 540, which makes it continue the same direction. That's a complete creative decision on your part if you have a mechanism like this. Okay, so let's go ahead and add a gumball. Let's place a gumball. And I want it to start directly above this hole. And let's go ahead and on that cylinder, that angle that we use to spin it, let us suppress this temporarily. It allows us, it's like the same as deleting, except we can then uncheck suppress. It will go back and we don't have to do anything. All the animations in Inventor Studio are still going to work fine. So let's do a tangent constraint. This is going to be one that we delete later of that to that plane. Apply, and then another one from there to there. Hit OK, and that's how the gumball would sit in this on that cradle until this comes to a point where it can fall in. And so I want it touching those two parts because that's where it would rest, but that gumball also would be, well, where we're going to start it. Let's go ahead and mate a plane, constrain, let's mate without predicted to that work plane we made before, on the cylinder. I think it was called work plane 4. Hit OK. And now it is in the right location for it to be collected. It's directly centered on that. But because I want it to move, I'm not going to be able to do that with these two tangent constraints. So what I'm going to do is constrain the center point of the gumball to a few origin planes, and that's how we're going to move it around space, around the area. So let us mate the center point of the gumball predicted to the universe's, not that one because I already have that one constrained with the work plane, to the ground. Apparently it is currently 21.302 inches off the ground. And we will accept that and delete the tangent constraint that it breaks. Delete. And then we can constrain the center point of the gumball to the origin plane that goes the other way, predicted. Hit OK and accept it and delete the other tangent constraint. And now it is locked in place, up and down this direction and going along the same direction as the cylinder using that work plane. So let's go ahead and go into Inventor Studio and animate this. And so we have this gumball. We need it to, we're not going to have it move off of this plane. We're going to have it move towards the center and then down as it falls into the collector. And I guess it unsuppresses. Oh, the suppress thing doesn't help you out once you get to Studio. So let's just make it look like that temporarily. Inventor Studio, timeline. I don't think oh, that is still there. Weird. Okay, so we want it to go to. Actually, let's go ahead and unsuppress, re-unsuppress that constraint. Let's set this to 180, and because we need to animate the gumball in this reality where the cylinder turns, and so we want that gumball to start moving as it gets to there, right about there-ish. And the constraint of the gumball going, the distance of the center of the gumball to the center of our universe is currently 0.676, and we want it to end up centered on everything, so we're going to animate this from 0.676 to 0 over the course of, we'll decide later. So as it goes like that, well, we definitely need it to be later than that. Let's we want it to start moving in about there to collect it, and that's not too bad. And we need it to also go farther down, which is the constraint that's keeping it from the ground, which is currently 21.302. And we're going to animate this to go, looks like one gumball. Let's see how, wait, 20 inches off the ground, if that is too far. Yeah, well, first of all, let's not have it start going downward until there. And does that look too far? That looks too far. That's not that bad. Is it sticking out the other side? A little bit. You can see that little piece of purple there. And let's save everything, why not, and turn off the visibility of this because it's not helping anything. Back to Inventor Studio. and we have it go in, and it's there, so let's not have it go as far down. This is from 21.302 to 20. Even, let's make it 20.125, because why not? And let's see, yeah, okay. So that, I think, is going to be good for that. And it can probably, you can see how it starts moving down. I think it cuts into the that plastic part, the clear part. Yeah. So we don't want it to start moving downward until about there. Although once it does start moving downward, we want it to fall pretty good. There we go. Okay, so now the knob turns around. First, let's make sure that we are happy with the speed of things. Yeah, that's pretty good. Okay, so the knob turns all the way around, and when it gets to this point, we want the gumball to go all the way down. And in fact, let's go ahead and edit this to have acceleration 100% because it is accelerating because of gravity. And so is this. This isn't going to be super noticeable, but on longer runs it will be. But because we've done that, now we can copy and paste this animation, which is it. This is the one moving up and down. Let's copy it and paste it. And it is also an acceleration of 100%, but it doesn't nearly go far enough. We need it to go down until it hits here, and we are going to kind of eyeball that. If this is 18 and that's 20, let's see what 17 does. That's pretty good. Not quite. 17.25. Oh wait, no, it'd be the other way. 16.75, because this is the distance off of the ground that it needs to go to. What about 16.9, 16.8? There we go. Hit OK. And let's see what we got so far. Constantly checking to make sure things work well. It looks like it starts a little quick, so we don't want it to start coming down until that. That's when we want it to start falling. Let's watch it again. Maybe a little sooner. A little slow, maybe a little sooner, a little faster and sooner. That's not too bad. Okay, so let's finish Inventor Studio, save it, and we are going to do a trick. And the trick is that we are actually going to place another gumball right here, and we're going to have one fade out and one fade in instantaneously, so it looks like the same thing. But then we will be able to animate the second one and have it do this complex spiral animation, and we will see if that works. So first, what do we know about the second one? We know we want it to be touching the face of the green part, which it sort of is. And let us mate the gumball center point. Oh wait, we're working with gumball 2 now. The center point directly below the axis of that with an offset of 0. Okay. And I don't think that's enough. We need, think about which way it's going to move. It's going to move well, we're definitely going to have to delete that because it's constrained directly below the hole there, and we want it to move around, which is most of the time not directly below the hole. So we're going to end up deleting that. We just want it to be in that place while we do a predicted mate of the center point to let's go here and hit OK, and let's accept it. And which one's it going to break? We'll break the tangent. Let's get rid of this one and see if that helps. Yeah, there we go. Okay, so right now it is constrained to or away from the ground by 18 inches, or nearly 19, and it's also constrained touching the green. Let's see, how does it still move? It still moves that way. Okay, so we want it to sit in the, let's undo that, let's put it back where it was. We want the gumball to not fall off the edge or go towards the middle, so we're going to predicted mate the center point to the center axis of everything, which is the y-axis, the vertical axis, and it's currently 1.852 away, and that might break something, but no. Okay, one way to check is to change this from -18, so 18 away from the ground, to let's see what happens if we make it -15. If it slides down, we're good. Okay, I think that's right. So let's put it back. Let's save it. Let's go to Environments, Inventor Studio, and the Gumball 2. Because of the way we've constrained this, I think this will work. The only constraint we need to animate is this one, because this constraint will keep it in contact with the spiral, and this constraint will keep it 1.852 inches away from the center of everything. So in theory, let's animate this constraint down to, let's see what -2 does over the course of 4 seconds. I think it will take 4 seconds, and let's hope. And a good trick, wait, it didn't really do that, did it? Oh yeah, it did do that. A good trick to keep from having everything break when you're using tangents and transitional constraints is, instead of clicking and dragging the playhead, just use play forward and play backwards and stop, and that will be good for things. Okay, so let's have Gumball 2 waiting, and we need to have Gumball 1 disappear right at that moment. And they're not lined up exactly, but that's okay for now. We need Gumball 1. How did that happen? I'm not sure. Here's what we can do. We can increase the distance this is away. Let's see what 2 does. That should push it a little farther away. And see back here in Studio. That's a little closer, and it actually will be pretty good. Let's right-click on Gumball 1 and have it disappear right at that moment. Gumball 1, animate fade. We're going to have it go from 100% opaque to 0% opaque, as to say invisible. And the animation part in the timeline looks like this. We don't want it to start becoming invisible until it lands, which is about right there, because this is it going to the ground. I'll have it disappear a little sooner just so you can see what happens. Well, here we have it disappearing over the course of a few seconds. I think this isn't going to break things. Yeah. So we have it slowly becoming opaque. It actually needs to happen instantaneously. That's to say go poof. And instead of it going to the ground, don't break, yeah. We want it to disappear when it lands. And I'll prove it to you by turning off the visibility of the second one. And as it comes to the ground, it should go poof, which is not yet. Let's have it go another 10th. There we go. Okay, so we have that working.
Good morning, Blazers.
Now we need to make the Gumball 2 be invisible up into this point. And do we have the Gumball 2 working? We do. We need to make Gumball 2, let's turn on visibility, and let's animate a fade from 100% to 0% at instantaneously starting at 0 and ending at 0, and hit OK. And so this Gumball 2 is invisible right now. And we want it to pop back into existence right as that one disappears. Let's go ahead and right click on its fade, animate fade, and we want it to go to 100% opaque instantaneously at this time. And it's very difficult to tell, but if I spread this out and have the one turning invisible turn invisible sooner, you can kind of see them take, not yet. Let's see what happens if they don't overlap. Stupid playhead. Yeah, so there are no gumballs there because there's no overlap. Okay, so this is Gumball 2 going from 0% to 100%. And so we need to make sure that turns on. You can kind of see that bump there where they switch, because that's the difference in distance away from the center, but that's close enough. And this is it going down the spiral. So let's see what this looks like, starting from the beginning. Hardly noticeable. And if you refined the distance, let's see if we can have them both visible temporarily. And let's put it right there. And let's put this down here. And let's see which one is too far. So this is number 1. Number 1 is a little bit too far to the, is it too far to the outside? I don't know, that's pretty close. And let's put it back there. Gumball 2. We want that to disappear when it hits the ground, and this one will take over. And let's play it. Okay, so now it's down on the ground, and we need to put in another one in order to get it to not dig into the ground. But actually, let's have this not go as far. We need it to be like -2.5, a little bit higher up. And this is where we're going to leave a third gumball to take its place. So Gumball 2 is now currently visible because it's starting out this entire black strip, it's invisible. Gumball 1 is going to stay invisible. It's still actually up there at the top where we left it, even though it's invisible. And so let's go back to that. We need to animate this fade, and we're going to have it go from 100 back to 0 instantaneously. and that will happen right there when it gets to the end, which is where we will get another gumball and leave it there for us. So let's go ahead and finish Studio and save it, and let's place another gumball, and let's see, where do we want it? We want it to be, let's start with a tangent of that to that. Hit OK, I think. And this is going to be Gumball 3. It is Gumball 3. And let's do an offset mate of that center point predicted off the ground, which is 0.5, which is half the diameter, and then we can delete that tangent, because tangents tend to be a little finicky. And we need to keep it, or have the Gumball 3 take over for Gumball 2, and we know Gumball 2 is always at any point during its animation 2 inches away from the center axis. So this one needs to start 2 inches, the center point, the distance from the center point to the center axis needs to be 2, and I think that's not going to break it. There we go. So let's put it over here, and we need to, we're actually going to delete that one also, because we want this to go, let's see if we can make this look right. This is what we want to do with this one, is have it go, you'll see it here in a second, I think, there we go. Have it go straight and then back over, which would be changing its distance from the center axis. But that's where I want it to start. So I'm going to put a constraint there and then use predicted constraints to lock it in there based on origin planes, and then delete that one, delete that 2 inch from the center axis. So let's do a predicted, the distance of that center point to the origin plane this way, which somehow is now, oh, because it wasn't perpendicular, that's fine. Hit OK. And constrain its center point predicted offset from the one going the other direction, which is probably XY. Hit OK. I don't think that will break it. Well, yeah, it did, but let's accept that and get rid of this one. I think it's locked in place. Yeah. And all of its constraints are based off of planes, so we'll be able to move it around. And we're not going to have to move this one, because it's going to, if it was rolling, it would always be on this surface right here. And we're just going to have to move it a little bit closer, well, when we animate it, closer to the center and farther away from that center to get it to go down the slope. So let's save it as we are. Let's go back to Studio, Timeline, and let's go ahead and play it until we want, where we want stuff to happen. Okay, and let's just nudge it forward. We are only dealing with Gumball 2 right now, and remember, we need to start with Gumball 3 invisible, so let's right click on it, go to Animate Fade. We'll go from 100 to 0, ending at 0, and instantaneously become invisible. So at the beginning of the video it's invisible, and we will right click on Animate Fade. Actually, let's put the playhead where we want it, which is what was it, like 6 point something, right there, whatever it is there. And we can right click Animate Fade, and we want it to instantaneously go to 100%. And then let's see what happens if we, how that transition looks. That looked pretty good. And so this is the Gumball 2 going around, but we don't want it to go around. We want it to, once it hits the end of the, or once it comes off the spiral there, we want it to go straight until it hits this edge right here, which is only going to need to animate its distance away from here. And we are currently negative 0.0, less than a tenth of an inch away from there, but it's going in the negative direction. Let's try negative 0.5. That is not enough. Let's edit it and let's go -1. We want to get as close as possible to that edge. 0.1. No. 0.2. Okay, 0.2. 0.3. How does that look? 0.3, maybe 0.27. Why not? Do it good. That's good. Okay, and we definitely don't want it to start moving there. Let's have it start moving right about there. Let's see. Let's hope moving this with the playhead doesn't break everything. You can see there where this one becomes visible too soon by a tenth of a second. And this movement right here, the acceleration of it. First, hold on, did I do that acceleration of the middle part? Yeah, this acceleration is not correct because this is rolling down, but it's still falling. It's accelerating due to gravity. So let's edit this, and you will see the difference in this, where the spiral kind of is going the same speed, but if we edit that movement so that it is accelerating the entire time, and play it, that definitely looks a lot more natural. The thing is, this second exchange is a continuation of that, where if we did, gravity acceleration for this one, it would start out at its slowest speed, which is not how things work, assuming we're trying to make it look like the same thing. It wouldn't slow down there. So what we're going to do is make this accelerate or travel at the same speed the entire time. It's not ideal. Theoretically, it should be continuing to accelerate, but it's definitely better than slowing up there, as it would be. Let's make it a little faster because it's only traveling that inch or so. And okay, so that's fine. And now we need it to go over to here. So we need to animate its distance from there. Animate constraint, which is probably going to be to, I think it's a ½ inch, -0.5, which would put us right there because of math. And we don't want it to start that movement sideways until it does its first stop, which is there. And let's have this go. This one, I still think constant speed at this point. Not sure. Let's see what that looks like. This definitely need to travel faster, or happen faster. And it wouldn't end up there, it would end up down here at the bottom. So we need to copy, well, you could just do another animation of its distance from the center, but I think we can just go ahead and copy this action and then paste it. And there's the bell. Fantastic. And this would happen at the same time as its movement towards the center. That is clearly too far. So let's edit this and let's go only -2. That's not enough. 2.2. 5. Hit OK. And let's see what we got there. It still looks slow. Let's see if we can do it even faster. And another bell. That looks pretty good. And the final touch is making it bounce, which this last movement we can mirror. Same thing with this one, mirror. And I think in theory it should go down and bounce back. The second one is probably going to be a little bit slower. Second one, the mirror one, which, what happened to us? There we go. Okay, this one right here, is it moving from there to there? This one and this one are moving from there to there. And another bell. Lovely. And so this last one, is it moving back up? Both of these should be decelerating the entire time because they are going up. So let's specify decelerate 100%. And same thing with this one. Edit acceleration, specify decelerate 100%. And let's see how fast. That's still going to look pretty fast, I think. Maybe a little bit slower, and then we can mirror these to put it back in the little corner there. There you go, not too bad. And technically this travels on a diagonal path from its final resting spot during the bounce, but that looks pretty good, and that's good enough for our purposes. So let's see the entire thing with the case back on, and let's jump back. Let's see if it breaks it. Good. Okay. Luckily the tangent constraint isn't breaking very much today. So let's see here. We have it go around, drops in, it drops down, becomes the next one seamlessly, and curls around. Perfect. And for the camera, there are other videos out there that can show you, other videos of mine. And the key to doing that is focusing in on what's happening. So at the beginning you would start with something, oh, there we go, it broke. The key is starting in with something that is sort of zoomed out, and then at this point I would probably, well, even sooner than that, I would probably start like this, and then I'd zoom in to maybe there and watch it drop, and then maybe zoom back out to watch it spiral, and then end with it zooming on that. Okay, that is spiral animation gumball.